So welcome to the next part of vectors. In this video, we'll be mathematically deriving a formula for the parallelogram law of vector addition. So if you remember in the previous video, we saw what the parallelogram law was and what the triangle law was. In this video, we'll be deriving a mathematical expression for the parallelogram law. So let's start off by drawing two vectors, namely p bar and one more, namely q bar. So we have two vectors, we have p bar and q bar. So if you remember right from my previous video, the first step in order to find your resultant is to finish the parallelogram formed by these two vectors. And the way you do that would be by drawing a vector that's parallel to this, starting from the head of this vector, and then another vector parallel to this vector, all the way coinciding with the head of this vector. Yes. So now if you notice, the resultant vector would be the vector joining the intersection of these two vectors and these two vectors. So this is going to be our resultant vector, or r bar. Okay, so now how do we proceed? What do we do and how do we get an expression? So first of all, let's consider the angle between p bar and q bar to be theta. So I'm just going to write that over here for reference. So let's say angle between p bar and q bar equals theta. And a warning that I'm going to give you guys right now, this derivation is going to include quite a bit of mathematics from your 10th and 9th standards. I won't be revising on those things, basic things like Pythagoras theorem and everything. So you guys must be knowing all that. If you don't know, please go check out another video and come back here. Okay, moving on. So the angle between p bar and q bar is theta. So the first thing that I would be doing over here is a small construction. So what I'm going to do, I'm going to start off from this point and I'm going to bring down a perpendicular. Okay, and I'm going to extend this vector like this. Okay, so now this is a 90-degree angle. This is the point of intersection and this is a 90-degree angle. So now what I'm going to do, I'm going to name all of the points. Okay, so let's say this is A, this is B, this is C, this is D, and this is E. Okay, so now if you observe closely, BA is nothing but p bar, because AB would happen to be minus p bar. So BA is equal to p bar, then BC is q bar, BC is q bar, and finally BE is r bar. Okay, so now let's move on to the derivation. So after this small construction, what I would be considering is I would consider this triangle BED. So in right angle triangle, it's right angle because this is a 90-degree angle, right? So in right angled triangle BED, this triangle BED, using Pythagoras theorem, BD square plus DE square is equal to BE square. It's obvious, right? The sum of the squares of two adjacent sides of a triangle would be equal to the square of the hypotenuse. So this is the basic Pythagoras theorem that you guys learned, right? So now this is the simple derivation. So after this, what I would do, BD square is this, right? So this is nothing but addition of BC and CD. So I would interchange and write BD somewhat like this, BC plus CD whole square, because BD is BC plus CD. BC plus CD gives BD, correct? So DE square, I'm going to maintain that as it is. So plus DE square gives BE square. So now I'm going to expand this. A plus B whole square is equal to A square plus B square plus 2AB. So this one I can write it as, one second. So this one I can write this as BC square plus CD square plus 2BC into CD, correct? So now this entire expression, I'm going to write it over here. So this entire expression will come up to be BC square plus CD square plus 2 BC times CD plus DE square over here is equal to BE square. Makes sense now? So now what I'm going to replace all this BC, CD and BC with things that we know like P bar, Q bar and R bar. Okay. So what I will be doing now is BC, right? BC is nothing but Q over here. So this is nothing but Q bar. So we can first replace that. Okay, there's another BC over here. This one is also B Q bar. So how we can write this in another way over here? BC square is nothing but Q square. So you have Q square plus, of course you have CD square plus 2 times BC is nothing but Q into you have CD remaining plus DE square, that is this, is equal to BE is nothing but your R bar. BE is nothing but your R bar is equal to R square. So now this is what the equation comes down to. So now we're going to simplify this further. What we're going to do now is in this triangle, okay, in CED, in triangle CED, if you observe carefully, we can again apply Pythagoras theorem over here, correct? If we apply Pythagoras theorem over here, we would end up with something like CD square, which is this, plus DE square, which is this, is equal to CE square, correct? Again, the sum of squares of two adjacent sides of triangle is equal to the hypotenuse squared. So CD square plus DE square is equal to CE square. So now if you observe over here in this equation, this big final equation, we have CD square plus DE square. CD square plus DE square. This is nothing but CE square. So I can replace this and this with CE square. If I do that, I'll end up with Q square plus CE square plus 2 times Q times CD is equal to R square. Okay. So now CE, correct? What is CE from the equation? This is CE, correct? Now this is the same as AB bar or P bar, because these both are parallel and it's the same vector, correct? What I told you in the previous video was when you draw a parallel line to this and this is ultimately like this is P and this is Q. That's what we're doing, right? Because opposite sides of parallelogram are equal. So this one is again P bar, nothing but P bar. So if CE is nothing but P bar, so CE square will become P square, obviously. So now you have Q square plus P square plus 2 times Q times CD is equal to R square. Okay, so the final constraint of us is the final constraint that we have is of CD. How can we write CD in something that we know using the vectors that we know, correct? So let's figure out a solution for that now. So now in this triangle, once again in triangle CED, in triangle CED, if you observe, we wanted somehow to get out CD, correct? So now since this angle is theta, this angle too will be theta. Makes sense, because same line, parallel lines, one straight line, and you have a straight line and 2 lines parallel, they'll make the same angle with the horizontal line. Makes sense, right? So now this one is also theta. If this also happens to be theta, you guys must be knowing using Pythagoras theorem and other trigonometry that you learned in 10th standard, the values of cos theta and sin theta. So cos theta over here, what will cos theta be? Cos theta is nothing but adjacent by hypotenuse. So adjacent is CD, hypotenuse is CE. Now CE is nothing but P bar. So now cos theta is equal to CD by P, correct? So with this I can say CD, that is this, is equal to P cos theta. So now if I substitute the value of this CD over here, what would I end up with? I would end up with Q square plus P square plus 2P Q cos theta is equal to R square. So now with this we can end up the final derivation saying the resultant vector or R bar is equal to under root Q square plus P square plus 2P Q cos theta. So now this is the derivation we were trying to get. Okay, so whenever you have two vectors p bar and q bar and you want to find the resultant using the parallelogram law, this is the derivation you can straight away apply. So r bar is equal to the first vector squared plus the second vector squared plus 2 times the first vector times the second vector times cos of the angle between them, which is theta. So now a very common question arises, correct? When you say q square, what is q square? How do I multiply two vectors, correct? How do I multiply a vector with itself? So when for example, if I give you, let's say, your q vector to be I cap plus 2j cap plus 3k cap. Okay, this is the vector I'm giving you. So now, how do I find the square of this, correct? It's a very common question that arises. This will be covered in the next video where we talk about vector multiplication. So hold on till that. It's enough if you understand the proof part of this. So the physical significance of q square, p square, and what you get by multiplying two vectors, I'll be covering in the next video, in which we'll be starting with vector multiplication. Anyways, this video is not yet done because there's one more aspect that I have to cover. Okay, so one minor correction from the previous derivation that we did. If you observe over here, I mentioned r bar to be this, but in fact it isn't r bar, it is just r, the magnitude of the vector, not the direction. Okay, so it's just r is equal to under root q square plus 3 square plus 2pq cos theta. So now if we move on, this was the formula we derived earlier. So this gives you the magnitude of the resultant vector. So now if you want to find out the direction of the resultant vector, right, because the vector must have magnitude and direction, so it makes sense only if we include the direction aspect to this, we have the magnitude aspect. So how do you tell the direction of this vector? So we're going to do the same thing that we did last time, okay, the same diagram. I'm going to start off with the same kind of construction over here. Bring out a perpendicular, extend this happens to be 90, name all your paths A, B, C, D, E. Okay, the naming is different from the previous diagram, but that doesn't matter. So now let's take the angle made by the resultant with the vector horizontal, or the horizontal vector, or the vector parallel to the x-axis, to be alpha. Angle made with the resultant with the vector that's parallel to the x-axis is alpha. So now if you see tan alpha is tan of anything is opposite by adjacent in a right angle triangle. So opposite side is CD, adjacent side is AD. So now this is nothing but CD, we can keep that as it is for now. What is AD? AD is this. AD is nothing but AE plus ED, because this entire thing AD is nothing but sum of AE and ED. Okay, so AD is AE plus ED. So now if you continue CD, let's keep that as it is, CD by AE is nothing but Q bar, AE is nothing but Q plus ED. So now the only things stopping us from getting a good derivation is this constant CD and ED. So now how do we express that in terms of vectors that we know? Once again, in triangle CED, so in triangle CED, this triangle, okay, so first of all, this is theta because the angle between A, P and Q are theta, so this is again theta. So now sine of theta is nothing but opposite by hypotenuse, so opposite is CD, hypotenuse is P, correct? So with this we know CD is equal to P sine theta, and again cos theta is equal to adjacent by hypotenuse, that is nothing but ED by CE, CE is nothing but again P, so ED is equal to P cos theta. So now we have a value for CD and ED, so CD and ED we just substitute these same things. So now tan alpha is equal to CD is nothing but P sine theta by Q plus P cos theta. So now alpha is nothing but tan inverse P sine theta by Q plus P cos theta. So now this gives you the direction of the resultant vector with respect to this vector and this vector. So now if you want a full derivation or a full result, it's the combination of this derivation over here. This gives you the magnitude and this gives you the direction. So alpha gives you the direction and this r bar gives you the magnitude. So the combination of these two is going to give you an idea of what the resultant vector is given two vectors, namely p and q. Let's move on to the next part, in which we deal with vector multiplication. So once I deal with vector multiplication, it will be quite clear for you what the p square, q square and pq means. So let's move on.